Hi everyone, I'm Ke Gong.
I'm Yifei Song.
Hi everyone, I'm Zhi.
Hi everyone, this is Han Junwei.
Today we are going to analyze Ukraine war-related tweets using deep learning models. Since the beginning of this year, the conflict between Russia and Ukraine has drawn global attention. And to better understand English-speaking Twitter users' reaction to this conflict, we use bidirectional LSTM model to analyze the sentiments, and then use the LDA model to discover underlying topics that is governing the discussion. We also visualize our results to further explore how the emotions change over time and possible relations between the topics and the emotions. This is the outlook of our project. For the collected tweets since February to May 2022, we first pre-process them and then feed them into two models. First, the bidirectional LSTM model to predict emotions, and then the LDA model to discover the underlying topics and classify them into clusters. For the pre-processing part, we first remove special characters, including emojis and retweets. Then we transform all the letters into lower cases and delete words with length less than 2, because these kind of words are really meaningless. And then we remove stop words, which are words that are generated when we extract text from the internet. Lastly, we will lemmatize the word.
Okay, let's talk about sentiment analysis. Next. In this part, we implemented a bidirectional LSTM model for multi-level sentiment classification. As the embedding layer, we used the graph model and created an embedding matrix for the input texts. Then we created a bidirectional LSTM model layer, each with 128 units. As we know, LSTM model is often used to model contextual information in natural language processing tasks. However, LSTM model also has a problem. It cannot encode information from back to the front. When classifying at a finer granularity, attention needs to be paid to the interaction between emotion words, degree words, and negation words. The bidirectional semantic dependencies can be better captured by LSTM. Finally, we apply the sigmoid activation function to lead to the multi-label outputs. Next. Our model produces a multi-label accuracy of 55% and F1 microscore of 0.65, and either exceeds or matches the performance level of the state-of-the-art systems. The matrix we adopted to measure the performance of the model are F1 microscore and J-curve distance. As we can see from the plot, since the accuracy and the F1 microscore decrease after 0.37, we have chosen the threshold to be 0.37 based on this performance evaluation.
Now we will visualize some results of some of our bidirectional LSTM models. For the first tweet, we can see that our model says that it exhibits some the sentiments such as joy. And for the second tweet, our model predicts it has sentiments such as disgust and anger. And we can see that those predictions match our expectations for those tweets. And next, we plot the Twitter sentiment evaluation from February 24 to May 1st, 2022. We can see that sentiments such as anger and disgust has a predominant frequency compared to other sentiments such as trust and love. And also for sentiments such as anger and disgust, we observe a gradually decreasing trend. And for sentiments such as love or joy, we observe like a gradually increasing trend. The next plot shows like the positive sentiments group with the negative sentiments group. We can see that the negative sentiments group nearly double the size of the positive sentiments group from the whole period. And lastly, we will visualize a misclassified example. For this tweet, our model says that it exhibits sentiments such as joy and sadness. This is a terrible example because the predictions are contradicted. So one possible explanation is that our model cannot classify like a tweet that's associated with our 11 labels.
In this part, we will be using the LDA model to gain a deeper understanding of the Ukraine-Russia war Twitter dataset. LDA is an unsupervised method that allowed us to detect latent topics that govern words in text. In other words, by using LDA, we can find some natural group of items, even when we're not sure what we are looking for. The general structure of LDA is shown as here. With the pre-processed dataset as the input, our LDA model will eventually output a file that contains all the topics made of all the words with the probability to belong to that topic. And now let's have a look at the visualization. The topic 10 is one of the latent topics we learned from our dataset. Let's have a closer look at the word in our dataset. We can see here that life, good, protect, freedom, hope, stand, and love are classified as the same topic as Ukraine and Zelensky. But in topic 6, war crimes, genocide, stop war, stop Putin now are categorized in the same group with Putin, Russia. And now let's go back to the slide, please. We see that our model does capture some sort of latent topic among words. By doing this topic modeling, we can conduct human analysis to define such topics more precisely. And this human intervention allows us to capture some extra sentiments that we have not included in our training dataset. For example, in topic 10, we see all words related to Ukraine has the sentiments known as positive, but in our training dataset, we do not have observation related to this sentiment. And this lack of training observation will eventually disable our model to predict such a sentiment. Hence, we should find more relevant observation and allow our model to predict more appropriate results. In conclusion, the sentiment analysis model does give us a better understanding about the general public opinion from the English world to the war between Ukraine and Russia. However, 11 sentiments are certainly not enough for the model to summarize the millions of online discussion effectively. And by using LDA model, we're able to further understand the model concerned topic. And for topic modeling, it can help us to improve our sentiment analysis model by exploring sentiment with high frequency that are not covered in our 11 labels and add more appropriate sentiment observation to train our model. Besides, it gives us the insight that some of the group shows a strong attitude towards different objects, such as anti-war attitude for Putin and the supportive attitude for Zelensky. In the future, we can add this extra information that collected by human intervention to assess our sentiment analysis model will more appropriate keyword. We would expect more appropriate result. And this is our presentation. And thank you for your time and lesson. In the end, on behalf of the entire team, may the work be active. Thank you.
Thank you.
Thank you.